example that we just saw on Desmos, I should have mentioned the importance of the degree of the numerator and denominator. So when the degree of the numerator and denominator are the same, the graph will approach a horizontal asymptote. Which can be determined by dividing the coefficients of the highest degree terms. In the example above, this would be one divided by one. So the equation of the horizontal asymptote is y equals 1. Moving back to Desmos, I'm going to put y equals 1, and you can see basically the red graph approaching that. One important thing about horizontal asymptotes versus vertical asymptotes, the graph of a function can pass through a horizontal asymptote but not a vertical asymptote. When the degree of the numerator is less than the denominator, the x-axis is a horizontal asymptote for the function. For the function. Think of y equals 1 over x. The numerator has degree 0, the denominator has degree 1. And of course its graph looks like this. But in some cases, as I said, the graph can pass through a horizontal asymptote. We'll get to those examples in a bit. The next example is going to demonstrate what happens if the degree of the numerator is 1 greater than the degree of the denominator. So example 3. Graph f at x equals x squared plus x minus 6 over x minus 4. Once again, we should factor all parts. F at x, the numerator factors to x plus 3, x minus 2, so there's no value of x that makes both the numerator and denominator equal to 0, so no holes. We can see that we have x-intercepts at -3 and 2. We have a vertical asymptote at the value of x that makes the denominator equal to 0 at x equals 4. But the graph where the degree is 1 greater has what we call a slant asymptote or oblique asymptote. To determine the the equation of that slant asymptote, we could go back to some of our knowledge of dividing polynomials, or we could just do synthetic division. So the equation of the slant asymptote, slant or oblique asymptote, we'll put 4 there because we're dividing by x minus 4. Write the coefficients, 1, 1, -6. Bring down the 1. 4 times 1 is 4. 1 plus 4 is 5. 4 times 5 is 20. Adding, we get 14. So we know that obviously x minus 4 is not a factor of the numerator because we get this remainder. These other two things are actually the coefficients of the equation of the oblique asymptote. So it's 1x plus 5. Now, if we switch back to Desmos, I've already got this equation entered. I will get rid of some of these things. I'm going to need to zoom out a little bit here. And as we said, there was going to be a vertical asymptote at 4. So I'm going to change this to 4, and we'll graph the so there you can see the vertical asymptote. I'm also going to put in the equation of the slant asymptote, y equals x plus 5. And as you can see, the graph approaches that red line. Of course, in this particular section of the graph, we have a little maximum point here, and over here we have a minimum. But the graph is kind of contained between the vertical asymptote and the slant asymptote in both cases.